All right, so ionic is always a metal bonding to a non-metal. And this is what happens. Remember, things bond based on their valence electrons. So a metal is going to lose electrons. And I just wrote that shorthand. My E negative means electrons because electrons have a negative charge. So if metals are the ones that are always going to lose electrons, what type of charge will my metals have? Positive charge. That's right. So my metals are going to lose the electron, so they are going to become my positive ions. And we have a special name for the positive ions. What are they called? Cations is right. So your metal, again, is always going to be first in the chemical formula. It's always going to lose the electrons, and it's always going to be your cation or your positive ion. Now, on the other end of that compound, you have another element, and it is going to be a non-metal. Once in a while, it may be a metalloid, but most likely it's going to be a non-metal. And so if metal is losing electrons, what's the non-metal going to do? It's going to gain the electrons. Is exactly right. So if it is gaining electrons, what type of ion does it become? It becomes the negative ion with a negative charge. And we call those anions. That's right. Anions. They have those special names. So again, ionic, always a metal, giving away electrons, bonded to a non-metal that's taking the electrons. Your metal is going to have the positive charge. Your non-metal is going to have a negative charge. So what do we know about opposite charges? What do? Do they oppose or attract? Opposite charges. The opposites always attract. So that force of the positive and negative are what's going to hold those two elements together. There's a force pulling them in. It's the opposite and negative, opposite charges, positive and negative, of those elements that they have. So let's look at a very common example. Let's look at sodium chloride. Sodium is Na, and it is a metal. It's a very soft metal. It's a very reactive metal. It will catch fire when it comes in contact with water. Chlorine is a gas. It's a poisonous gas. It will get into your lungs and it will kill you. Not a good thing. By themselves, super harmful to people. But when they bond together, when you add them together, they react and they make something that is something that we like, salt, right? It makes that crystalline structure of salt. Doesn't look anything like a metal. It doesn't look anything like a poisonous gas, and we eat it all the time on our French fries and popcorn, or they're no good. So what's happening here is happening on the valence electron level. So sodium is in family group 1. How many valence electrons does sodium have? It's in family group 1. It has 1 valence electron. Everything in family group 1 has 1 valence. Chlorine is in family group 17. How many valence electrons does chlorine have? Not 17, 7. If you remember that octet rule, it says all elements need how many electrons? 8 valence electrons to be what? Stable. So if we're looking at trying to get 8 valence electrons, sodium has 1 and chlorine has 7. I put 6. It has 7. There we go. I saw Jalen counting. He was like, he caught my mistake. All right, so right here, chlorine has a blank, an opening. And sodium has 1 to give. Now what happens is if sodium can get rid of that electron, it drops down an energy level and it's stable, because underneath, this is only the valence electrons, so underneath that level it's stable. So if it can get rid of that electron, it drops down an energy level and it's stable. So this happens to be just what it needs. It needs a place to give that electron to, and chlorine says, I will take it. So sodium is going to give its electron to chlorine, and that's gonna fill that spot right there. So when this happens, now your oxidation number told you it was going to happen, because sodium has a +1 oxidation number, meaning it's going to give 1 electron away. So once that actually happens, sodium has a +1 charge. Chlorine has a spot to take. It's got an oxidation number of a -1, meaning it has one spot that it can fit in with and gain an electron. So once that happens, it takes on the electron. It does have a -1 charge. So if I've got a positive and a negative, they're held together in a bond and they become NaCl, which is sodium, right, it is table salt, but the real name for that is sodium chloride. So pay close attention right here to the end. You know, we started off with chlorine, and once it bonds, it changed to an ending of not INE, but IDE, which is chloride. Anytime it bonds, or the non-metal bonds at the end, the second element, it's going to change to the ending IDE. It kind of signifies a name change, like when two people get married, usually one of the people changes their names. In our custom, it's usually the female changes the name and takes the name of the male. Not always the case. Some people don't change their names. You don't have to. But when there's a name change, it signifies that a bond has happened. It's just a symbol. So that's what's happened here. This name has changed from chlorine to chloride, and that signifies that it has reacted. And once it reacts, that compound is now stable, and it's not going to react. So when you eat the salt on your French fries, it's not going to, you know, do a lot of damage unless you eat too much salt, right? Too much salt is bad. Too little salt is also bad, but you got just right. Make sense? Ish. Let's do another one like that. Let's take calcium and oxygen. So if I do calcium, which is Ca, and oxygen, which is O, and just looking at their valence electrons, calcium has how many valence electrons? 2, right? Because calcium is in family group 2, up and down, family group 2. So calcium has 2 valence. Oxygen, how many does oxygen have? 6, right? Because oxygen is in family group 16. Everything in family group 16 has 6 electrons, valence electrons. So, can you kind of predict what's fixing to happen here? From calcium, right? Calcium has 2 to give away. Once calcium gives its 2 away, it's going to drop down an energy level, and it's going to be stable. Oxygen needs 2 to be stable. So, again, they are a match made in heaven. Calcium is going to give its electrons to oxygen. Calcium is then going to have a +2 charge. Oxygen is going to have a -2 charge. And those opposites are going to keep that compound together. And when I name this compound, when I write the chemical formula, I'm going to write calcium, big C, little a. And then oxygen goes the next letter like this. That's how we write a chemical formula, with a big O. Each capital letter tells you you're dealing with a new element. And when we call the name from this, we call the element, the metal at the beginning, calcium. And then oxygen becomes oxide because it has bonded. So calcium oxide is totally different than what calcium is by itself and oxygen is by itself, because a new substance has been formed. It has new properties. Okay? Is that a little bit clearer? Questions over ionic bonds before we move on? Can I go back? Yes, right here. Like that? Yes. You got it? Okay. Any clarifications? So ionic, let's review right here. It's always going to be between a metal and a non-metal. The metal's always going to lose the electron and become your positive ion. Your non-metal's always going to gain and become your negative ion, your anion. And it's always going to be a metal and non-metal. That's how you know. All right, let's look at covalent. If I look at the word covalent, I should be able, it should send some signals up in my head if I break it down. So what does it mean to cooperate? To act right. To do what? To work with each other, right? Cooperatively, to share, to play nice, right? To share. And that's what's happening here. Now, if I cover up the co, you see the part valent. So if I look at valent, what does that sound a lot like? We've been saying a lot of valence electrons. So if I'm working with sharing valence electrons, what am I doing? Sharing my valence electrons is exactly right. So how you know something has a covalent bond is two nonmetals. So it's a nonmetal plus another nonmetal. So these two things are going to bond together and they are going to share electrons, specifically the valence electrons. They're sharing valence electrons to become stable. So if they're sharing, nobody's taking, nobody's giving, we are not going to have any charges. So I'm going to write in big capital letters, no charges. Now, when you oxygen, yes, it has an oxidation number. It can gain 2 electrons. But if it is bonded covalently, it's just sharing. It's not actually getting charged because it's not taking any. It's just going to share. So it can work both ways. So let's look at something. When you inhale a lot of air mixture and hopefully oxygen's in there somewhere. When you exhale, what do you blow out? Carbon dioxide. So let's look at carbon dioxide. What 2 elements do you think are involved in carbon dioxide? What 2? Carbon is for one, and what's the other for one? Oxygen is right. Can y'all see the word oxygen kind of in that dioxide? Y'all recognize that oxygen is the element? Good. All right, so carbon is a non-metal. Oxygen is a non-metal. So they are going to covalently bond to make carbon dioxide. So let's look at this and see what's going to happen. How many valence electrons does carbon have? Nope. Look again. Look at your periodic table. What family group is it in? It's in 14, and everybody in family group 14 has 4. So it has 4, right? The oxidation is a positive or negative 4, but it has 4 electrons. That positive or negative means it can gain or lose. But remember, we're not gaining or losing anything right here because this is covalent. We're sharing, right? We're covalent. We're playing nice with each other. Nobody's taking or giving electrons away. All right? Oxygen, how many valence electrons does it have? 6, right? So it has 6 valence electrons. Again, it does have an oxidation number of a -2, meaning it can gain 2. But again, this is covalent. We're sharing. We're not taking or giving, so there's no charges involved here. But the same concept is true. It still needs 8 to be stable. So oxygen has 2 openings to make 8. You following me? Okay. So carbon has a pair of 2 right here that's going to give to oxygen. They're not going to give it, though. Not going to give it, and it's not going to take it. What are they going to do with it? Share. They're sharing those electrons. They're not giving and taking. They're sharing them. So they kind of go back and forth between the elements. They're sharing. So no charges. They're just sharing. But if you notice on carbon, I have 2 more electrons that need a home. But I only have carbon and oxygen, so what's going to have to happen?
Oh, I know.
No, I can't stack them, yeah.
And it's going to be a
Nope, because we're not, the only charges happen is when you give or take, and we're just sharing.
You can share 2 from over there.
I can share 2 from, but I've got those 2 slots are filled. Let me give you a hint. This'll probably, you're going to see it now. The chemical formula for carbon dioxide is that. Does that help? Like, I can't just leave it. It's got it. Those two have to go somewhere. CO2. What does this little 2 meaning?
Exponent.
It kind of like an exponent. It's a subscript, but it's there's an extra something I need. Nope, you're close. Nope. Say it. You're close. You're so close. How many oxygen atoms are in CO2? Ah, there we go. Now we are on fire. Very good. So there are 2 oxygens in this compound. And that explains why carbon needs 2 oxygens, because it has 4 valence electrons. You agree? You see that? And if it only bonds with 1 oxygen, 2 of its electrons don't have a home, and they need a home. And so it wants to share with another oxygen. And now you have CO2. You have a carbon, and now everything is plugged in. 2 of its electrons plug into 1 oxygen, and the other 2 electrons plug into another oxygen. So CO2 is carbon dioxide. Carbon dioxide. So that's what you're exhaling. Dioxide, if you look here, it's got a prefix, di, and that means 2. The prefix di means 2. All right. The next one we're going to look at is water. Water really makes a polar bond, but it's a covalent. They still share electrons. So let's look at water. What is water's chemical formula? H2O. You know it already. So the H2O is water. So if that means I have how many hydrogen atoms? 2 hydrogen atoms. All right. How many oxygen atoms? 1. Okay. Now let's look at the valence electrons. How many valence electrons does hydrogen have?
1.
Okay, so each atom of hydrogen has 1 valence electron. You got 2. Oxygen has how many valence? 6. So oxygen has 2 spots where it can share with each one of those hydrogen. There you go. So each hydrogen has 1 that it can share with oxygen, and oxygen has 2 spots. So that's why it needs 2 hydrogens to fit in to those spots. So you have H2O, you have water. If I were to name this and use the scientific name for this, I would use the prefix 2 as di, hydrogen, meaning I have 2 hydrogens, and I have 1 oxygen, so that is monoxide. Sounds very, very chemically, right? Chemically. So dihydrogen monoxide is the scientific name for water, what we call water. Just like sodium chloride is what we call salt. All right. Okay. So just to review, you got 2 types of bonds in this class. So anytime you see a type of bond, I swear, on EOC, if they have metallic or polar or anything like that, that's not the answer. If you have a test and it's got another type of bond that's not ionic or covalent, it's not the answer. It's not that you forgot or you were not listening that day and you think it is. It's not the answer because it's not in our standard. What's in our standard is ionic and covalent. That's it. So it's either ionic, meaning it's a metal and a nonmetal, or it's covalent. It's 2 nonmetals. If it's ionic, it's giving and taking electrons and being charged. If it's covalent, it's sharing. It's playing nice. It's 2 nonmetals. They're all happy, right? And everything does that based on that octet, because every element needs 8 valence electrons to be what? Stable. And all elements are trying to get stable. That's why they react. Questions? Clarifications? What ifs?